Hello friends, myself R.D. Mazen presenting my new video on shifting theorem from inverse Laplace transform. Its statement is like this: if inverse of f bar of s is f of t, then inverse of f of s plus a is equal to e raised to minus at into f of t. Means if s is replaced by s plus a, then we have to multiply that f of t by e raised to minus at. And inverse of f bar of s minus a, as here s is replaced by s minus a, we have to multiply that f of t by e raised to plus at. Then using this theorem, we try to derive two important results. The first one, inverse Laplace of 1 upon s minus a raised to n. As here it is replaced s by s minus a, it becomes a problem of shifting theorem. And whenever it is replaced by s minus a, we have to multiply by e raised to at to inverse of, neglect that a, remaining term is 1 upon s raised to n. We have to obtain the inverse of that term. And as per standard result, e raised to at as it is, inverse of 1 by s raised to n, we have two results: t raised to n minus 1 divided by gamma n, or we have e raised to at into t raised to n minus 1, and the value of gamma n, when it is positive integer, its value is n minus 1 factorial if n is positive integer. Therefore, remember these two different formulas. Whenever it is positive integer, we have to apply this one, and if it is not positive integer, we have to use the first one. Then another result, inverse Laplace of 1 upon s plus a whole raised to n. Here s is replaced by s plus a, and as it is replaced by s plus a, it is a problem of shifting theorem. And as per that shifting theorem, it is e raised to minus at, e raised to minus at into inverse of, neglecting that plus a, remaining term is 1 by s raised to n. And its inverse, we have two results once again. Therefore, it is e raised to minus at t raised to n minus 1 divided by gamma n, or we have another value as e raised to minus at t raised to n minus 1, and the value of gamma n, when it is positive integer, it is n minus 1 factorial if n is positive integer. And therefore, remember these two important results derived with the help of shifting theorem. And after knowing these three results, we try to solve some simple example based on this shifting theorem. First example, find inverse Laplace of 1 upon s minus 3 whole raised to 4. As s is replaced by s minus 3, it is the problem of shifting theorem, and therefore that inverse of 1 upon s minus 3 whole raised to 4, as per the previous formula, whatever I have discussed just, it is e raised to 3t, as s replaced by s minus 3, it is e raised to 3t into inverse of, neglect this 3, the remaining term is 1 by s raised to 4. Here the power 4 is positive integer, and whenever it is positive integer, its inverse is, therefore e raised to 3t as it is t raised to 4 minus 1 divided by same factorial, that is 4 minus 1 factorial, and therefore we get the value as e raised to 3t, t raised to 3, and divided by 4 minus 1, it is 3 factorial, and therefore final answer is e raised to 3t, t cube, and 3 factorial is 6. is the required answer, or required inverse Laplace transform. Second example, find inverse Laplace of 1 upon s plus 2 and whole raised to 5 by 2. The power n is here not positive integer, and therefore, and another as s replaced by s plus 2, it is a problem of shifting theorem, and therefore inverse Laplace of 1 upon s plus 2 whole raised to 5 by 2 is equal to e raised to minus 2t as s replaced by s plus 2, and into inverse of remaining term, neglecting that 2, remaining term is 1 by s to 5 by 2, and as it is not positive integer, as per the standard result, its inverse is, therefore e raised to minus 2t, as it is no change, it is t raised to 5 by 2 minus 1 divided by gamma of n, that is 5 by 2. Then whenever we require to find the value of gamma, try to express in the form of gamma n plus 1, and therefore it is e raised to minus 2t, t raised to 5 minus 2, that is 3 by 2, and divided by gamma of 5 by 2 I can rewrite as 3 by 2 plus 1. And then find the value, therefore e raised to minus 2t, t raised to 3 by 2, gamma n plus 1 is n gamma n, right, or use it continuously till we get the value of gamma 1 by 2. Therefore this I can rewrite as 3 by 2 into 1 by 2 into gamma 1 by 2. What result I am using here? That is gamma n plus 1 as n gamma n. And another standard result, gamma of 1 by 2, the value is root pi. And therefore, it becomes, this is equals to 4 by 3 e raised to minus 2t, t raised to 3 by 2, and the value of gamma 1 by 2 is root pi as the required answer or required value. Example number third, find inverse Laplace of 3 divided by s minus 1 whole square plus 9 means 3 square. As here s is replaced by s minus 1, it is a problem of shifting theorem, and therefore we can rewrite that inverse problem 3 divided by s minus 1 whole square plus 9 means 3 square. 3 I can take outside, and as s is replaced by s minus 1, we have to multiply inverse by e raised to plus 80, a is here 1, therefore e raised to t, and into inverse of, neglecting that 1, the remaining term is 1 upon s square plus 3 square, and then using standard result we get, it is 3 e raised to t, 1 upon s square plus a square, its inverse is 1 by a, 1 by 3, sine of at, sine of 3t. Therefore 3 get cancelled, we get final answer as e raised to t sine of 3t. Very simple. Watch the video up to end so that all basic results are clear to you. I am taking very simple examples to explain the use of this shifting theorem, and if you know how we can use it or how we can apply it, you can solve any type of problem based on shifting theorem. Therefore try to watch all the 6 examples very carefully. Watch the video up to end. Next example, example number 4. Find inverse Laplace of s plus 2 whole divided by s plus 2 whole square plus 16. 16 means 4 square. Here there are 2 terms of s, one in numerator and another in denominator. Everywhere it is replaced by s plus 2, and therefore it becomes a problem of shifting theorem. Therefore, to find the value, we have to rewrite that inverse Laplace of s plus 2 whole divided by s plus 2 whole square and plus 16 means 4 square. As s is replaced by s plus 2, it is equals to e raised to minus 2t, as it is replaced by s plus a A is here 2, and therefore it is e raised to minus 8t means minus 2t e raised to, into inverse Laplace of, neglecting that 2 from numerator and denominator, the remaining terms are s divided by s square plus 4 square. And as per standard result, it is e raised to minus 2t. S upon s square plus a square is cos of 8t means here it is cos of 4t as a required answer. Example number 5th. Find inverse Laplace of 1 upon s minus 3 whole square minus 64. 64 means 8 square. And therefore, rewriting it, inverse Laplace of 1 upon s minus 3 whole square, 1 upon s minus 3 whole square minus 8 square. As s simplified by s minus 3, it is a problem of shifting theorem. Therefore, it is e raised to 8t plus, therefore e raised to 3t into inverse of, neglecting this 3, remaining terms are 1 upon s square minus 8 square. And using standard result of inverse Laplace, it is e raised to 3t. 1 upon s square minus a square, its inverse is 1 by a sin h a t. A is here 8 means 1 by 8 sin hyperbolic of 80 is the required answer or required value of that inverse Laplace transform. Last example, find inverse Laplace of s plus 4 whole divided by s plus 4 whole square minus 36 means 6s square. As here both s are replaced by s plus 4 means it is a problem of shifting theorem, and therefore we can rewrite that given problem, inverse of s plus 4 whole divided by s plus 4 whole square minus 36 means 6 square. As s replaced by s plus a type of term, it is e raised to minus 80 means minus 40. A is here 4 into inverse of remaining term, neglecting that 4. Remaining terms are s divided by s square minus 6 square. And as per standard result, it is e raised to minus 40. Inverse Laplace of s upon s square minus a square is cos hyperbolic 80. A is here 6 as the required answer. Therefore, in this video, I try to explain very simple examples, 6 examples based on this shifting theorem. If you have any difficulty, please mention your difficulty in the comment box. I will try to answer your query. If you like my video, please share it, as well as subscribe to my channel if you are not subscribed yet, to receive the notification for my such type of new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.